Okay, good afternoon, everyone. Dr. Jensen here. So today we're going to talk about lab reports. Now, this topic tends to be a little bit variable depending on your professor. A lot of these things are somewhat preferential. They're not hard rules for things. The things in this video I'm using more for my class and how I generally do things. Okay, so again, when we're doing lab reports, again, this is more for my class, and usually, again, there's always going to be due dates for when things are due. Usually we're doing things the week after we do reports, and every lab that we do, we will write a formal lab report. So again, in some classes, there's some variations of formality and reports that get written. But for us, everything is going to be pretty much the same. So everything is written as a formal lab report. Um, Generally, every professor is going to have their own preference of lab report formats. This is the one that I generally follow. This is the one that a lot of professors will probably go with. Again, most of this information is usually given to you in some kind of, if you have a lab book or some kind of lab procedural handout that you're following. So a lot of this is information that you have on hand already. Now for my class, the various sections, pretty much everything through the pre-lab questions is stuff that you can get in the handouts that I get. So really my only general rule for writing lab reports is that you don't give me back my PDF documents, that you write your own reports. Okay. So usually in general chemistry, every lab that we do, a lot of times when you get a lab book, they talk about what are the learning objectives, right? So that's not really the purpose of doing the lab oftentimes, because sometimes, like when we do volumetric analysis, right, it's a titration lab for acids and bases. They may say things like the objective is to learn how to use certain pieces of equipment. But in the real world, that's not the purpose of doing the experiment. That's not why we would do a titration. It's not to learn about titrations, right? When you're on the job, you are doing the experiment for a specific purpose. And so oftentimes I will direct you to focus on what is the purpose of doing the experiment, not the things that you're supposed to learn from it. Because obviously that you're supposed to learn things, but if we focus on real world applications, then the more we get used to, okay, I'm doing this for a reason. I'm doing this to get paid. This is my job. I have to present this to someone that I expect to get money for. Putting this kind of mentality helps you to gauge like what kinds of work you're turning in. Okay, especially at the college level, because again, you should be thinking about the quality of work that you turn in. If you're getting paid for it, okay, that's what you should be thinking about. Am I getting paid for this work? If I'm turning in something written on the back of a napkin, do I expect to get paid for that? Would you pay someone for that? Right? So the quality of work that we should be turning in, we should be conscious of the real world applications that we're using it for. We are giving someone a report that they are paying for, right? And so the purpose is, in most of our experiments, in a lot of our experiments, again, and this varies based on chemistry class, a lot of our general chemistry work focuses on finding unknowns, right? So we want to determine concentrations. We want to determine identities of things. These are generally unknowns within the lab. So the labs have both the purpose and they have the focus of, again, chemistry, and a lot of these labs are very analytical. And so a big portion of analytical chemistry is determining compositions and things like that. All right. For my class, I don't really care about the procedure as much. You just need to have a procedure section. You can, again, you have a handout or a lab notebook conceivably. And so different professors will say they want you to rewrite the procedure, or they want you paraphrase the procedure. Paraphrasing the procedure is a good thing to get into. It helps with our practice of paraphrasing in general, so you don't get into areas of plagiarizing. But for me, I don't really care as much. As long as you have a procedure section, really, again, the only thing I advise against for any of my students is I don't want my documents back, and I don't want a C lab handout, right? So usually a good way of doing it is after you've done the lab, what steps in the procedure did you actually do? Like capturing the actual steps that you did in your lab notebook, and then using that as your procedure. Most of the labs that we do, generally there are pre-lab questions. For my class, you don't have to do a lot of these things in advance of the lab, but they are submitted with the lab report. Okay. Now the data sections in general chemistry, in most lab reports, they give you a data section. Like they have data tables drawn out for you because they are trying to help you learn how should I organize my information? What kinds of information should I be collecting? And so you want to recreate your practicing of what kind of data should I be collecting? You're recreating the data section in your document. So again, this works on things like our soft skills, things like doing tables in Word, and utilizing the kind of prepackaged information to help guide you towards the kinds of data that you're going to collect. So when you go into the lab, you kind of have some idea of, okay, we're going to take temperature measurements. So that means I need columns in order to take temperature measurements that go with time measurements, that kind of thing. Again, the same kind of thing goes here is presumably I would prefer not to, I don't want my documents back. Again, even though the data tables are already pre-printed for you, you may have written down your notes in your data section, but you should remake that in an actual document. Again, we are preparing a professional report. So if you're doing things in a professional report, there's not handwritten scribbled notes in there. You translate it into your Word document. Also like pictures of your notes and things like that. Yes, you can throw PDFs and things like that into your document, but you don't want to do that. You want to produce a finalized report that is something you're going to provide to your client. So conclusions can differ greatly in different classes. Now, at the general chemistry level, you're just learning how to do lab reports. So generally the conclusions are not super long, okay? So this is obviously different as you get up into higher levels to where there's more information and more data being collected. And so conclusions can be longer, or data requires more analysis. And so there can be different sections that come with this. Sometimes they're called discussion or summary or conclusion. And again, this differs based on science too. Is if you're in a psychology class and you're doing a lab, then there may be more of a discussion section rather than summary or conclusion. But these terms are not synonyms. Okay, so if we're thinking about, a summary is just recapping of the data. Okay, so you collected a set of data, you're just summarizing the important pieces of data. Okay, but that's not really a conclusion. There's no analysis that happens with that. Okay, you're looking at how, what does the data mean? That's the analysis part. That's what a conclusion is inferring, is that there is some further analysis that goes with it. Okay. So in general, when we are writing conclusions, these are some keys that are they're kind of universal. So it usually doesn't matter what class you're in. Generally, the type of writing that you do for a conclusion is fairly similar. Generally, we write in paragraph format. Okay, so that means complete sentences. Okay, generally, if we're doing scientific writing, we generally want to write in the tense of third person objective. So this usually means I, me, we, the experimenter. It's taking yourself out of the conversation. Okay, so we're removing ourselves from the conversation of what does the data mean? So we're trying to avoid bias by interjecting how we felt about it, how we think about it, or what, you know, how we are involved in the setup. Okay, so we're looking for complete and logical sentences, a complete a paragraph. So most of our general chemistry labs are not super long, so writing a paragraph or a conclusion shouldn't really be more than a paragraph. So if you've written more than a paragraph for most of the general chemistry labs, you probably went too far. Because again, we're looking for brevity. We're looking for concise. It should have just the pertinent amount of information. Okay. We want to be able to use data from our data section in our conclusion. Okay. But our conclusion should be focused on what was the purpose of doing the experiment. Okay. So I generally outline there's 4 basic parts of how I would see a conclusion. Okay. So first off, the purpose. Okay. What is the purpose of doing the experiment? Okay. So if if your doctor wants to draw blood, why do they want to draw blood? Right. They want to check your cholesterol. Okay. So the purpose of the experiment is to check your cholesterol, to check your heart health, right? So often restating what was the objective or purpose of the experiment can help set the tone of where we're going with the paragraph. Okay. Methodology, generally, how did we go about doing this? So this is just a sentence that we're trying to be as concise as possible to summarize how did we go about testing our hypothesis. So for example, in our volumetric analysis lab, we are using titrations as a way to find concentration. Or in our physical properties lab, we use calibration curves. So we use a calibration curve with standards in order to determine the concentration of an unknown, right? And so then, okay, so we've discovered, what was the purpose of doing the experiment? How exactly did we go about testing that hypothesis or purpose? And then what was the result? So if we're doing qualitative analysis or quantitative analysis, if there's numerical values that we derive from the experiment, we should put those in the conclusion. But this is also the time where generally a lot of general chemistry students have difficulty in that when I say we should put data in the conclusion, they give me a whole bunch of data in their conclusion. And it's like, okay, I don't need to know things like the mass of your beakers. Okay. I don't need to know the concentration of all your standards. Okay. If the purpose was to determine the concentration of the unknown, that is a piece of data that I would have needed. If there are maybe 2 parts of your experiment, because in a lot of parts of an experiment, we do 2 parts, maybe the first part is doing your calibration curve, or we're standardizing sodium hydroxide for titrations. Oftentimes we do standardization. So we standardized our base, and then we use the base to determine the concentration of an acid. So what was the result of part A? What was the result of part B? If there were numerical values, those 2 should show up in your conclusion. So it's an exercise in trying to learn what things were important. Okay. So this goes into things like our logical thinking process. What information did you need to get towards the conclusion? Okay. If we're looking at concentrations of solutions, yes, you may have had 5 standards, but telling someone that you had standards of 10, 20, 50%, that doesn't really, it may not mean anything, right? It may not mean much to anybody. So, those are in the data section, but it's not really important enough to re-emphasize in the conclusion. Okay. Maybe, the output of your calibration curve with your equation and the R² value showing that, a calibration curve was done. It generated an equation for a line. It had an R² value of 0.99, right? So you're saying, this was the output of the calibration curve. It was fairly linear. And then from there, your unknown was determined to be X, right? So So sometimes it's a little bit of trial and error. Okay, so some people don't quite pick up on the I don't need to put every piece of data in there. Some people go for kind of a shotgun approach where they're throwing data in there, hoping that something in there catches the reader's eye, right? But again, when the focus or purpose of writing the conclusion is brevity, is trying to be concise, is trying to be data forward and information forward, and giving your client what they need, what did they pay for, okay, giving extraneous information is not always beneficial, okay. So some labs then further go on to an analysis. What does the data mean? Some labs that we do, there's not really further analysis. Like if we're determining the concentration of calcium chloride, it doesn't mean anything, right? The calcium chloride is just a solution. It's a salt solution. It doesn't have any particular meaning beyond you found its concentration. But in other labs, like for our second semester chemistry class, we do something like a hard water analysis. So we're doing an environmental sample of calcium in the water. And so there is some further meaning to that. The hard water may have further health effects, like if we're testing our water for lead content, right? If I want to know how much lead is in my water and I say, well, you have 5 ppm of lead in your water, it's like, okay, is that a good number? Is that a bad number? What does that number mean? So there is further analysis to help your client or your reader to understand that 5 ppm is above the EPA safe level and you shouldn't drink this water. Okay. Think of the same thing of like getting a blood test. Okay. Your doctor doesn't just say your cholesterol was 120. Thank you for your copay. Okay. What does the 120 cholesterol mean? Okay, well, it means, okay, here it's on the high side, you need to, or on the higher normal side. And so you need to take XYZ steps in order to, bring that number down. Okay, so not all of the labs will have that further analysis, but if there is, we should include it in there. Okay, and so here's an example where I highlight the calcium standard one. So this is from our hard water analysis. And so here you can see the various parts of what I was trying to outline. Okay, so we have the purpose of the experiment. We want to know what is the calcium concentration. We used pH titration as our methodology. There's some little extra part in there talking about what was their standards that we measured it against. Step 3, we found there was 2 parts. We found the concentration of the EDTA. And then in part B, we also found the concentration of the calcium. And then this, what does this value mean? It means the water is moderately hard according to the EPA. That's the analysis of what that number means. Okay, so we have to think about these things. So again, for most of the labs, you're looking at, what was the purpose of doing the experiment? Very brief, how did you go about doing it? And then what was the result? And then if there's something else to it, what does that result mean? Then there may be the analysis part. And for general chemistry class, there may not be more to it than the first 3 steps. Okay, but if you cover the first 3 steps, that really gives the reader exactly what they need. What are they paying for? Okay, what information did I need to get out of my cholesterol test? Okay, I needed to know, what was my cholesterol. Okay, so giving me numerical values. It shouldn't be between numbers. Okay, so when we're talking about chemistry work, we should be thinking about analytical values. It shouldn't be between 2 numbers. It shouldn't be about something. It shouldn't be around something. Okay, if you have numerical value, the whole reason of doing analytical data is to get analytical results. And so if there is a single number, you should give that single number. Okay, if there were multiple numbers, you should probably average them to get a single number. Okay, not your unknown was somewhere between copper and iron, right? So it's like that leaves kind of a lot of ground to cover between those elements if we're trying to determine what is the identity of something. Okay, so you are the expert here. At least for my class, I generally don't have the unknown list in front of me, so I'm relying on you to give me the answer. So if you tell me the EDTA was 65 ppm, I accept your analysis. Okay. If I redo your calculations and find your concentration was actually 2 ppm, then that's when I would disagree with you for what you got. Right. So, but for the most part, I'm looking for you to direct the reader to what is the answer. Okay. So let's recap here just real quick. Okay. This is the lab report format that I want you to follow. Name, title, purpose, procedure, pre-lab questions, data section, and conclusion. Okay. These things don't have to be done before the lab. They just have to be done for the final lab report. Okay. Most of this stuff is in your lab handouts. We'll collect the data section when we go to class, and then you write the conclusion. Your conclusions really shouldn't be more than a paragraph, okay, for most of these labs. All right. All right. Well, I will be back later with another video talking about specifically some of the some specific labs that we'll talk about.